Time behaves predictably, or so we thought. Enter time crystals, a newly discovered phase of matter that defies some of the most basic rules of physics. They might just change how we understand the universe. So what exactly is a time crystal? Imagine a regular crystal like quartz. It has a repeating structure in space, symmetrical, organized and stable. Time crystals take this concept but apply it to time. Instead of patterns repeating across space, they repeat across time. Imagine flipping a light switch on and off at precise intervals without ever touching it. Time crystals behave like that, oscillating between states indefinitely. Sounds weird? It is. Physicist Frank Wilczek first proposed the idea of time crystals in 2012. Back then, people thought he was just playing theoretical gymnastics. Many scientists believed such a thing couldn't exist, but in 2016, a team at the University of Maryland proved them wrong by creating the world's first time crystal using a chain of ytterbium ions manipulated with laser pulses. Not long after, Google's quantum computing team successfully created one inside their Sycamore quantum processor. So what's with the ytterbium ions and laser pulses? Ytterbium ions are atoms that have been stripped of some electrons, giving them a positive charge. Scientists arranged these ions in a straight line using electromagnetic traps, basically an invisible cage made of electric and magnetic fields. This setup kept the ions perfectly still. Then came the lasers. Researchers hit the ytterbium ions with two types of laser pulses, one that flipped the ions' quantum states and another that created controlled interactions between the ions. These precisely timed pulses created a system where the ions switched states in a stable rhythm, like a clock ticking in perfect sync. Now here's the key breakthrough. The ions oscillated at half the frequency of the laser pulses. Why is that significant? Imagine tapping your finger on a table every second. Normally, you'd expect a reaction, like a vibration or echo, to match your rhythm. But in this case, the ions responded at every other tap, once every 2 seconds instead of one. This behavior is impossible in ordinary materials and was a clear sign the system had entered a time crystal phase. The system was effectively ignoring some of the energy input and responding in its own delayed rhythm, a unique feature of time crystals that breaks the normal rules of physics. Here's the twist. This doesn't violate energy laws because the system isn't actually generating energy. It's just cycling between states in a predictable rhythm. That's what makes them special. Time crystals exist in a non-equilibrium state, a system that never fully stabilizes yet never falls apart either. The simplest way to imagine this is with a swing. If you push a swing every 2 seconds, you'd expect it to move in sync with your pushes. But what if the swing only moved every 4 seconds instead? That delayed, stable rhythm is how time crystals behave. They beat to a slower tempo than the energy driving them. It's called, and it's one of the wildest phenomena in modern physics. Now, you might be thinking, cool science trick, but why should I care? Well, time crystals have huge potential for technology. Quantum computers are notoriously unstable. Their delicate quantum states can break down easily. But if qubits can be stabilized in time crystal states, we could create quantum processors that are vastly more reliable. This could unlock faster data processing, improved encryption, and breakthroughs in materials science. There's more. Time crystals could drastically improve atomic clocks, the devices that set the gold standard for precision timing. Atomic clocks work by measuring the natural vibrations of atoms to track time down to billionths of a second. They're critical for GPS, telecommunications, and scientific research. Because time crystals oscillate in a highly stable and predictable rhythm, they could make atomic clocks even more accurate and robust. This would lead to better GPS accuracy, improved internet synchronization, and sharper astronomical observations. In short, this discovery opens the door to innovations we haven't even imagined yet. In fact, researchers at Stanford are exploring ways to use time crystals for stabilizing quantum networks, potentially creating unhackable communication systems. Meanwhile, Google's Sycamore team is investigating how time crystals could help correct quantum computing errors, which is one of the biggest hurdles to commercializing quantum tech. But time crystals aren't exactly plug-and-play tech just yet. Creating them still requires highly controlled environments like those found in quantum labs. Plus, they demand precise energy pulses to maintain their unique behavior. Scaling this up for practical use is an ongoing challenge. Still, the fact that we now have a phase of matter that appears to defy equilibrium is mind-blowing. It rewrites what we thought was possible. Imagine future quantum systems that never lose stability or sensors that can measure the tiniest vibrations in space-time. Time crystals could make that happen. We're just scratching the surface here. Time crystals are young in the world of science, but they may turn out to be one of the most powerful tools we've ever uncovered. If you thought quantum mechanics was weird before, well, buckle up, because the strangest discoveries are yet to come. Curious about more mind-bending science? Stick around and subscribe, because reality is only getting weirder from here.